Hello to you newcomers and welcome back subscribers. This is Big Baby Props and I'm the Big Baby. In today's video I'm going to show you guys a way to drastically reduce your amount of print time and filament requirements for some of your 3D prints. I'm going to be using a Stormtrooper helmet as an example. Here we just have the top obviously, but this is a great way to illustrate what this process is going to be doing. So the top of the helmet is a bit flatter than most of the Clone Trooper helmets that I work with. So the problem I came across was when we went to add supports to protect some of the interior. Let's give it a pretty good angle of 65 degrees. Look how many supports it generates. That is a lot of plastic that doesn't even go into the final product. I'll have to just throw it away. So one, it's going to cost money because it'll be using filament. And two, it'll be costing time, which, time is money. So we're going to try and reduce the amount of supports as much as possible. Let's just see how long this will take to print. Okay, it looks like it'll take just under 40 hours. That's a whole work week. That is not ideal for one part of a helmet. So let's go over to Mesh Mixer and let's try and solve this problem. So what I'm going to be doing is creating sort of an interior part that will act as kind of a loft. It'll go up most of the way to the helmet, and instead of building supports all the way up, which I can show you here, are just basically solid plastic, all those lines, those go all the way down. Instead of doing that, we'll build a little object underneath of it that takes up most of that space. I'll show you guys what I mean. So let's hit this Mesh Mix button over here, the ball with the weird face on it. This will allow us to create an object inside of it. I'm going to use this cylinder since it kind of mimics the shape of the helmet, at least a little bit. Okay, and this is a bit too big. Let's scale it down a bit. That looks pretty good on the height. Maybe a little bit lower since we're going to try and spread it out around the helmet, and we'll bring it in this way, around there. We'll need to do the same for the other sides. We might be able to bring it out a little bit more. There, that looks pretty good. Now you want to be sure that it doesn't intersect with your helmet, because that'll take away from your actual object that you're trying to print. So I can see a little line right there. So that just means that they're intersecting a little bit. So I'll just bring it down a little bit. Yeah, that looks better. Okay, now that we've got our extra little object, let's just export it and we'll bring it into Simplify 3D. Okay, let's remember this 40 number so we have a nice thing to compare it to. Let's clear out the supports and let's import our object that we just made. Alright, there it is. You can kind of see what I'm talking about. We'll build the supports on top of it, and we'll just make this like a 1% infill or something, just so that the top here can be fleshed out before it starts building supports on it. So now let's go back and use the same overhang angle, 65, and generate supports. And clearly it doesn't look like any were made. Let's go ahead and print it and we can see them on the inside. Okay, we can already see that it is now about 30 hours instead of 40. That is already a great return. Let's look inside to see the supports built. If we drag this down a little bit, we can see layer by layer, and there it starts to build the supports. Those are up on the inside. If we keep dragging down, this is what the interior of our supporter body looks like. It's whatever the infill percentage you have in your print settings. So you can clearly see that this infill pattern uses a lot less plastic than this just support pattern, which is just, a bunch of lines. So that is how you reduce your print time when it comes to supports. This is a great method. Of course, you want to have at least a little bit of infill, especially if you have a big round object like this, because when it starts to try and print the roof right there on your object, you might get some sagging along these long lines here. So like 1 or 2, maximum 5% infill for this. Otherwise, you're just defeating the purpose of this whole method. So there you go, guys. Quick video today. I hope you learned something. I hope you guys are able to implement this in your own 3D printing. And I hope to see you guys again in the next video.